Hello, class. Welcome back. Hopefully, you're taking care of yourself and you're taking care of your family. This is week 3, part 1. I'm going to continue with the same format where we do, a video and an activity on, Monday. In the middle of the week, we'll go through another activity or another opportunity to review, and then on Friday, we'll go through some of the answers throughout the week. This topic that we've covered in at some point this year was based on triangles, so I'm going to kind of continue on that idea. I want to talk about a formula that only applies to one specific type of figure, one type of triangle, which is a right triangle. That would be the Pythagorean Theorem. That's where you find a missing wall on a triangle, and what the formula is. Now, if you're not familiar with the formula, again, I'm going to draw it right here in front of you, just so you know. It's based on a right triangle. The two legs, these are the legs, the two parts that touch the 90-degree angle. Those are A and B. I don't care which one's A and B, as long as they're touching the 90. This triangle could be turned any which way. And then the hypotenuse, which I will label as hype, that's the longest wall, that's going to be your C. That's the same setup for every type of right triangle. It's got to be a right triangle. AB are the walls that touch the 90, and then C is the hypotenuse. Now, the formula that I'm talking about is A squared plus B squared equals C squared. That's the formula we're going to be using throughout all these, these problems on this review, and also on the Google form, so they should be somewhat easy. And you'll get decimals, sometimes you get nice whole numbers. They're just kind of random. All right, so let's jump right in here. So this first one, we're going to be finding this part. Most of the problems always have an X on the picture, so I'm just putting the X on this one. We're going to be finding this missing wall. It looks like that is the hypotenuse. These are the A and B wall. They touch the 90. Doesn't matter which one's A and B. And then this is the C. So it looks like I'm going to be doing 12 squared plus 16 squared, and that's equal to x squared. Now, how I knew that is because this is the formula for the Pythagorean theorem. And it looks like on this particular problem, I'm missing C. It's not going to be every time. Just on this particular instance, I was missing the C. So doing the math here, 12 squared, that is 144. 16 squared, I believe that's 256 if I'm not mistaken. 16 times 16, yeah, 256. And adding these two things together here, let's see, 256 plus 144, I'm getting exactly 400. That's kind of nice. And then I'm going to take the square root to the other side. So the square root of 400. And again, why we do the square root, that's how you get rid of the square. It's the inverse operation to take it to the other side. You always have to do square roots on Pythagorean theorem problems. But the square root of 400, it's the number that multiplies on itself to gives you 400. It's exactly 20. 20 times 20 gives you 400. Now, again, you can type it in a calculator. Most cell phones have you just turn the cell phone to the side. You'll see the button. Now, how you type that in the calculator is different. Sometimes you have to type in the 400 first, then hit the square button. Sometimes you can actually hit the square button so it shows up in your screen, then type in 400. Depends on your calculator that you have. But it should give you a nice clean 20. No decimal. And that would be this wall right here. Now, again, it made sense on this one. The hypotenuse is the biggest wall, so it had to be bigger than 16. You just don't want it to be too big. All right, going to the next one. Now, this is kind of a weird shape. It's not a right triangle. On this problem, they wanted to know this wall, the missing wall. That's what it said in the book. Your problems have X's where they need to go. So I'm gonna move this so it is a right triangle. I'm gonna move this over. So I'm gonna make kind of a rectangle, and this 8 just slides in here. Now, when you do that, it shortens up this wall. It shortens up this wall, so this is 4. It makes like a nice clean rectangle. The 4 comes up, and then that makes this part 6. This piece from here to here. Now, why? It's because the whole top was 10. So that made sense. So the triangle we're actually dealing with here is this. That's a 6. That's a 8. And I'm looking at that piece right there. So it looks like I am missing the hypotenuse again on this one. This is my A, this is my B, and this is C. So 6 squared plus 8 squared equals x squared on this particular problem. This ends up being 36 plus 64. If I add these two together, I get an exact 100. And I take the square root of it. The square root of 100 actually is a nice clean 10. 10 times 10 is 100. All right, I know that's weird. It's just one of those things that kind of threw it out there to see what you see if you can kind of pay attention to all the different things we've done previously. All right, and the next one here, we're going to be finding the missing wall. The missing wall that's in question on this one is this height in the middle of my triangle. That's the part that we're going to be doing here. Now the bottom, Since this is an isosceles triangle, how I know it's isosceles, these two walls are the same. The bottom can be split in half, so this is 5 and 5. That might be something you remember or don't from previous lessons, but that's what we're going to do. So this is the triangle that's in question here. So so I'm missing this piece. This is the 5, and this is 13. So it looks like on this one, this is my A, this is B, and this is C. Again, A and B doesn't matter. So this is x squared plus 5 squared, because that's a squared plus b squared, equals the 13 squared. Now you can start to see, like, it's not always the hypotenuse that's missing. This is a perfect example. I'm missing the height in the middle of this triangle. And again, on your pictures, they always have an x. I threw these in here because I like these pictures. So on this one, this was 25. On the other side, I get a 169. That's 13 times 13. I'm going to subtract the 25 across. So if I subtract 169 and take the 25 off it, I should get a 144. And then I take the square root of that. And that's a nice clean 12. Now again, I'm not guaranteeing that yours will work out to be nice clean numbers. I'm just saying that, even if it's a decimal, that's the number you're gonna stick with. Go 1 or 2 decimal places if need be. But this is kind of what we're reviewing. I know we've done this previously in a different section, so I thought it'd be kind of nice. We've been talking about different categories of review that we should be covering, and this is a big one. Hopefully, again, you're taking care of yourself. I submitted a Google form to you, so you can try out a couple of these. Again, in the middle of the week, I'll submit a different activity, and at the end of the week, I'll go through the answers on the Google form. Again, take care of yourself, and I hope to see you soon.